Hello friends, Mr. Burrell here. We're in Unit 4. We just finished in Unit 4.1 and 4.2 talking about factoring and solving quadratic equations. So equations of this form, ax squared plus bx plus c equals 0. Degree 2 polynomials. We talked about factoring them, using those factors to solve quadratic equations. We talked about the quadratic formula as a way to solve quadratic equations. So we've dealt a lot in this year and last year with quadratic equations and how to go about factoring, dealing with, and solving those. So now we're going to extend that a little bit. We're not only concerned that quadratics are not the only kinds of polynomial functions we see functions of higher degree often. So we're going to talk about how to go about factoring and solving those kinds of functions. And one of the best ways that we can do that is using polynomial long division. So we'll talk about that. That's the main subject of this section. So the objectives, by the end of this lesson, this is what I hope that you know. I hope you know how to divide polynomials using polynomial long division and divide polynomials that have remainders, and we'll talk about that. In Unit 3, we talked about adding, subtracting, and multiplying polynomials. And I probably mentioned briefly, like, later, much later, we're going to talk about dividing polynomials because it's a process in and of itself. So hopefully we'll feel comfortable with adding, subtracting, and multiplying polynomials. Now we're going to talk about dividing polynomials and how to do that. So I had a video in our Canvas page right before this one, an Abbott and Costello video about dividing 7 into 28 and getting 13, or taking 7 times 13 and getting 28. And there was kind of some funny relationships in there and proofs about how Abbott, like, he proves to the other guy that 7 times 13 is indeed 28, which obviously it is not. So when we're talking about division, if we're reflecting all the way back into our elementary school days, we've done this division, so that's kind of a fun introduction to that. But we're going to start with division of numbers to kind of introduce and show you how we use those same principles, those same steps, those same relationships to divide polynomials. So we're going to complete this division problem using long division. Not using a calculator, just using long division. 172 divided by 4. And we're going to write down our steps right here. So if I'm taking 4 into 172, my first step that I need to take into account is what times the outside equals the inside. So I'm trying to determine what times the outside is going to equal the inside. So let's see this. How many times does 4 go into 1? Well, 4 doesn't go into 1. So I'm going to then ask myself, how many times does 4 go into 17? Or what times 4 is going to give me a number under 17? Well, 4 times 4 is 16, so that works. 4 times 4 is 16. And I'm going to go ahead and drop a 0 down here. So 4 times 4 is 16. I drop my 0. So that's my second step. I multiply. I multiply this number that I got on top by this number on the outside, and I write it under here. 4 times 4 is 16. My next step is I'm going to subtract, or I'm going to change the sign. So I need to subtract 160 from 172. So 2 minus 0 is 2, 7 minus 6 is 1, 1 minus 1 is 0, and I'm left with 12. And then I repeat the process all over again with this new row right here. So now I need to determine what times 4 is going to give me 12, or a number less than 12. So 4 goes into 12 3 times. So I've determined what times the outside equals the inside. That's 3. And then I'm going to multiply 3 times 4 to give me 4 times 3 is 12. Then I'm going to subtract, or change the sign here. 12 minus 12 is 0. And I'm done. I'm completely done. 4 can no longer go into 0. I'm not dropping anything down. 4 ends up dividing into 172 perfectly, 43 times. And if we wanted to go double check our math, 4 times 43 is indeed 172. So hopefully that kind of racked your brain back in the day when you were doing long division. We're going to use those same steps, these same principles, talking about dividing polynomials. So, let's look at an example. I have x cubed plus 2x squared minus 14 divided by x minus 3. So, and I've kind of done this one for us. So first thing I need to do is I'm going to write what I'm dividing by on the outside of the division symbol here. So this is my divisor. Right here is my divisor. And I'm dividing x minus 3 into x cubed plus 2x squared minus 14. This is the dividend. You don't need to necessarily memorize these terms, but they're good to know. Notice I have x cubed minus 2x squared, and I wrote in a plus 0x minus 4 because I don't have any x's here, so I'm putting in 0 x's to kind of hold my place there. And then my answer up here, as I go through the steps, this answer up here is going to be the quotient. This is going to be my answer. So, remember the steps that I just talked about when I was dividing numbers. Those steps are going to be the same steps that are applicable with dividing polynomials. So my first step, what times the outside? So what times the outside equals the inside? So I'm going to look at this first term right here. So what times x equals x cubed? Well, to get from x to x cubed, I have to multiply by x squared. What times the outside equals the inside? X squared. So I'm going to write x squared up on top above the x squared term as the first part of my quotient. So that's my first step. My second step is I need to multiply. So I need to multiply x squared times this term right here. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. So I distribute x squared, multiply it by this whole term, and I get x cubed minus 3x squared. Okay, now my next step is to subtract or change the signs. So you notice here, I'm going to go ahead and subtract this term by changing each of these signs. Remember, subtraction changes the signs. And I'm going to do this math. X cubed minus x cubed, well, that's 0, so that just goes away. Negative 2x squared plus 3x squared is a positive x squared. And then I'm going to go ahead and bring down my next term, this 0x. I'm going to bring down this term as the next term that's left in this polynomial, 0x. And then my last step is repeat. I'm going to do it again. So now I need to determine what times x, looking at this next row here, I'm going to divide this into chunks. Looking at this next row here, what times x is equal to x squared? Well, x times x is x squared. So I'm going to write x above the x term over here. And then x times x is x squared. X times negative 3 is negative 3x. So that was my second step. I multiply this quotient term by my divisor. X times x is x squared. X times negative 3 is negative 3x. Then my next step is to subtract or change the sign. So this turns into a negative x squared and a positive 3x. I do my math here. X squared minus x squared is 0. That goes away. 0x plus 3x is 3x. And then I bring down my negative 4. I bring down the next term. And then I repeat the process again. What times x is equal to 3x? Well, x times 3 is equal to 3x. So I write 3 up here on the quotient line, and then I multiply. 3 times x is 3x. 3 times negative 3 is negative 9. So I multiply down here, and then I subtract, or change the signs. Subtract here, add here. So 3x minus 3x is 0, and negative 4 plus 9 is a positive 5. So my answer here, x cubed plus 2x squared minus 14 divided by x minus 3 is equal to this. This is my quotient. So x squared plus x plus 3. And then this number that I have left is my remainder. My remainder means that this doesn't divide perfectly, exactly into this, so I have this as a remainder. So I have x squared plus x plus 3, and my remainder is 5 divided by my original divisor. So 5 divided by x minus 3. So that would be my final answer. X squared plus x plus 3 plus 5 over x minus 3. That is my answer. So in the upcoming units, we're going to talk about using polynomial long division. We're going to do some more examples, but in the upcoming units, the reason we use this is to break down polynomial functions that are a higher degree than a second degree polynomial, bigger than quadratics. This one was a cubic. I don't have a real good method to factor and solve a cubic expression, so I can use long division to break it down into a quadratic term that I am more comfortable solving. Okay, let's look at another example. Here I have, let me move my face out of the way, 4x cubed plus 2x squared minus 6x plus 3, plus 3, divided by x minus 3. So, here's my divisor, x minus 3. I'm dividing that into 4x cubed plus 2x squared minus 6x plus 3. So my first step, I'm looking at my very first term here. What times x is equal to 4x cubed? I need to have 4. I'm going to write this above the x squared term because it's going to end up being an x squared term. But 4x squared times x is 4x cubed. So that's my first step. 4x squared times x is 4x cubed. Now I need to multiply this term by both of these terms. So 4x squared times x is 4x cubed. 4x squared times negative 3 is negative 12x squared. And I write those terms underneath the terms that match with them, 4x cubed and 12x squared. My next step is I need to subtract or change the signs. So I'm going to go ahead and change the signs here. 4x cubed minus 4x cubed is 0, so I don't need to write that. 2x squared plus 12x squared is 14x squared. And I'm going to drop down my negative 6x. I'm going to draw a big line here. Now this is the new line where I'm going to repeat these steps again. This is my new dividend right here. So now I need to ask myself next, again, repeating, what times x is equal to 14x squared? Well, that's going to be 14, because 14 times x will give me 14x. And then I need x, because 14x times x is 14x squared. So 14x times x, this is my next step. I'm going to multiply 14x times x and 14x times negative 3. 14x times x is 14x squared. 14x times negative 3 is negative 42x. 14 times negative 3 is negative 42. So after I multiply those together, now I'm going to change the signs, or I'm going to subtract. 14x squared minus 14x squared is 0, so I can just ignore that. Negative 6x plus 42x is 36x. So I have my 36x. I'm going to drop down my positive 3. I'm going to drop down the next term. And I'm going to repeat. Now, again, this is my new dividend here. So what multiplied by x is 36x? Well, that's going to be 36. So 36, now I need to multiply 36 by both of these terms. 36 times x is 36x. 36 times negative 3, that's negative 108. I have this written down. I did this problem in advance. And then I need to subtract, or I need to change the signs. 36x minus 36x is 0. 3 plus 108 is 111. And x cannot go into 111 because it doesn't have an x. So I know that I'm done. This term can no longer go into this term. That's how I know that I'm done. So my answer, 4x cubed plus 2x squared minus 6x plus 3 divided by x minus 3 is 4x squared plus 14x plus 36, and I have a remainder, so plus 111 divided by x minus 3. So that is my answer. Those don't divide perfectly, so I have a remainder. That often happens. If you ever have a remainder of 0 here, if you get 0 in the very end, this part just goes away, and you're left with this polynomial as the quotient. But since I had a remainder here, I'll write that remainder over the divisor, or over x minus 3. Okay, let's do one more example. So I have 3n to the 4th minus 5n to the 3rd minus n squared minus 7n plus 9 divided by 3n minus 2. This one is a little bit more in depth, which is why I wanted to go over it so you can see a little bit more difficult problem. So I'm taking 3n minus 2 and I'm dividing that term into 3n to the 4th minus 5n to the 3rd minus n squared minus 7n plus 9. That's a long one. And first I recognize that I have a 4th degree, a 3rd degree, a 2nd degree, a 1st degree, and a constant term. So I don't need to add in any zeros or anything anywhere. So, let's start. My first step. I'm looking at 3n here, my first term. Notice on the other ones I just had like a variable. I just had x. This is the first one where we've had a number in front, and that's okay. So what multiplied by 3n gives me 3n to the 4th? Well, that's going to be 3n to the 3rd. Or sorry, just n to the 3rd. n to the 3rd times 3n is 3n to the 4th. So after I've found this quotient part here, I'm going to multiply n to the 3rd by both of these terms. n to the 3rd times 3n is 3n to the 4th. n to the 3rd times negative 2 is negative 2n to the 3rd. After I multiply, my next step is to subtract, or to change signs. Boop. 3n to the 4th minus 3n to the 4th is 0, so I don't need to worry about that. Negative 5n to the 3rd plus 2n to the 3rd is negative 3n to the 3rd. I'm going to drop down my next term, negative n squared, and I'm going to repeat. I'm going to draw a line here so I can keep everything separate. Now, what times 3n gives me negative 3n cubed? Well, that's going to be negative n squared, because negative times 3 is negative 3, n squared times n is n cubed. So that's good. Now that I've found that term, I'm going to multiply negative n squared by both of these terms. Negative n squared times 3n is negative 3n cubed. Negative n squared times negative 2 is a positive 2n squared. So I've multiplied negative n squared by this term here. Now I need to subtract or change signs. So I'm going to change all my signs here. I'm going to do this math here. Negative 3n cubed plus 3n cubed is 0. Negative n cubed minus 2n cubed is negative 3. Or sorry, negative n squared minus 2n squared is negative 3n squared. I'm going to drop down my negative 7n, and I'm going to repeat. So 3n minus 2. Now I need to, my next step, again, I'm repeating again, how many times, what times 3n is negative 3n squared? Well, I need the negative again. Negative times a positive 3 is a negative 3. And then what times n will give me n squared? Well, n will. n times n is n squared. So now I need to multiply negative n by both of these terms. Negative n times 3n is negative 3n squared. Negative n times negative 2 is a positive 2n, like so. Now that I've done that multiplication, I need to change the sign. So this turns into a positive, this turns into a negative. Negative 3n squared plus 3n squared is 0. Negative 7n minus 2n is negative 9n. We're getting close. We're getting real close. I'm going to drop down this last positive 9, and we're going to repeat on this line right here. So what times 3n is negative 9n? Well, that's going to be negative 3. Negative 3 times 3 is negative 9, and then I have the n here. So negative 3 times 3n is negative 9n. Oops. So now I need to multiply negative 3 times both of these terms. Negative 3 times 3n is negative 9n. Negative 3 times negative 2 is a positive 6. And then I need to subtract, or I need to change my signs. Negative 9n plus 9n is 0. 9 minus 6 is 3. What times 3n is equal to 3? Nothing. Nothing times 3n is going to be 3 because there's no variable here. So I know that I'm finished. I'm all the way done. So my answer here, when I divide 3n to the fourth minus 5n cubed minus n squared minus 7n plus 9 divided by 3n minus 2, I get n cubed minus n squared minus n minus 3 with the remainder of 3. So I'd write this as 3 over 3n minus 2. My remainder is 3, so I'd write it over my original divisor. N cubed minus n squared minus n minus 3 as my final answer. So that's long division. Again, in the upcoming sections that we talk about in these upcoming lessons, we'll talk about using long division to break down a large polynomial into a polynomial in a form that we're more comfortable solving. Because that's what we're all about with polynomial functions. Remember, we're worried about solving them, finding the solutions. So this is going to help us to do that. So at the end of this lesson, hopefully you are now able to do these things. Divide polynomials using polynomial long division, and divide polynomials that have remainders. And all the polynomials that we did in this example had remainders. Some of them will not, and that's okay. So I hope that was helpful. Please let me know if you have any questions whatsoever about polynomial long division. I hope that you enjoyed that as much as I did.